G'day again, Year 8s, and here we go for our third video for Chapter 2, and we are looking at, today, we are looking at triangles, exercise 2C. Alright, again, a little bit of a review. We have looked at a lot of this stuff, so let's go over this again. So, just a few little characteristics of a triangle. Obviously, a triangle has three sides. It's got three vertices. Remember, our vertices are the points of the triangle. Okay, I'll try and do a circle. It's not a very good one, but yep. There's one, there's two, there's three vertices. Okay. And it's also got three interior angles. So angle in here, an angle in there, and an angle in there as well. Okay. Remembering, I think this comes up anyway shortly, but those three angles always add up to, yep, 180 degrees. All right. Now I've got different triangles. Okay, they can be classified by their side lengths. All right, so we've got a scalene triangle. All right, and scalene means that all the side lengths, are different lengths, and all the angles are different sizes. All right, that is a scalene. All right, so all the side lengths are different from each other. There's no side length the same, and all the angles are also different. All right, an isosceles angle, we have two sides that are the same length, okay, identified by these dashes on the sides. They are the same length, and we also have two angles at the base of the triangle. Okay, as you can see, the base sitting along here down the bottom. All right, the two angles in the two corners there are equal. All right, they are equal angles. All right, and then the last one, we've got an equilateral triangle. So equilateral, equal meaning all the side lengths are the same length and all our angles are the same size, hence being equilateral. All right, so there are three different, major different types of triangles. A little bit more information. You can also, so that's classifying triangles by side lengths. All right, and it also has, depending on the side lengths, also means that it creates some different angles inside. But we can also classify triangles by their interior angles as well. Okay, so we can have an acute triangle, all right, where all the angles within the triangle are acute angles. That's less than 90 degrees. All right, so each of those angles will be less than 90 degrees, makes it an acute triangle. You have a right triangle, which means that one angle within the triangle is a, whoops, that's coming up again, and again, is a 90-degree angle. Okay, so a right angle triangle has one angle that is a 90-degree angle. And we've also got an obtuse angle, which means that we've got one angle that is an obtuse angle, so greater than 90 degrees or between 90 and 180 degrees. Okay, so that means that we've got an obtuse angle. Now these can pair up, so for instance a equilateral triangle that we had here, okay, can also be classified as an acute angle, obviously, because all the angles are less than 90 degrees. All right, so you can classify them in different ways, and the same and different classifications can be for the one triangle, if that makes sense. Okay, just like we had for the equilateral triangle, but it's also an acute triangle. Okay, as I said before, all the angles in a triangle add up to 180 degrees. Okay, so you all should know that. Now, this one, I don't know if we really covered this last year. All right, so this might be a little bit new, this point here, that when we extend one of the lines, so as you can see here, we've got our triangle here, but this line at the bottom, okay, I'll try and draw it as straight as I can, has been extended. All right, now when you extend a line like that, it creates an outside angle, so an angle outside of our triangle, as you can see there. Now that outside triangle, sorry, that exterior angle, we call that an exterior angle on the outside of the triangle, so the angles on the inside are called interior angles. So this exterior on the outside angle of the triangle is equal to the sum of the two opposite interior angles. All right, so the two opposite angles to this exterior one, so there and there, those two guys will always add up, when you add them together, will equal that exterior angle. All right, so it's a little thing, a little trick or a little bit of information that's very handy to know. Okay, so that exterior angle, the two opposite interior angles always add up to that exterior one. All right. So if this exterior angle, actually I'll change that, just say if this angle up here was 100 degrees and this angle was 60 degrees, this exterior angle would be 160 degrees. All right, so add those two guys up, equals that one. I think I've said that enough. All right, so knowing that information, so you may have to flick back to some of these key ideas that we've got here. I want you to show working out, and I want you to have a go at doing these two problems to begin with. So find the value of A in these triangles. So A is here, and then A is here, and you may need to identify various aspects of the triangles and the types of triangles that they may be. All right, so off you go, pause the video and have a go. All right, welcome back, crew. All right, to find angle A here is really simple. We haven't got any, well, here is, I suppose, a, what do we call it? Sorry, I got a mind blank myself, a scalene triangle. All right, because I think all the sides are looking different and all the angles are looking different. So we use our knowledge of knowing that all our interior angles of a triangle add up to 180 degrees. So what I'm going to do first is add up these two angles. So I'm going to add up my 92 and my 38. I'm going to add those guys together. 8 and 2 is 10. Carry the 1, that's a big 1. 9, 10, that's 13. So 130 degrees. Now I know that my triangle adds up to 180, so all I do now is my angle A equals 180 minus my 130. Really poor, I'm actually going to do that 130 again. There's 1 and 3, 0. So my angle A is going to equal 50 degrees. Now this is going to be the issue. There we go. So 50 degrees. All right, that's simple. So really, really easy. Okay, so now on the second triangle here, we've got to find angle A. All right, now we don't know this angle down here. We've got this angle up the top here, obviously. So we can't really use this method over here of going, well, we know the interior angle's all up to 180, so we can work this one out. Doesn't quite work like that. So we've actually got to have a look at more of the triangle that it is and the type of triangle. And as you can see here, we've got two side lengths that are the same. So these guys are the same length, okay? If we've got two sides that are the same length, like this, what does that mean about our two base or angles at the base of the triangle? That means these guys are going to be the same, okay? So if we're looking at isosceles triangle, that's what it is. These two angles at the bottom are going to be the same, all right? So we use that information to work this problem out, all right? So first thing I'm going to do is I'm going to say, well, if these are the same, they're going to be split. All right. So what I mean there is it. I know this is 26 degrees. So I'm going to do 180 minus my 26 degrees, and that is going to give me. It's really hard writing on this for some reason. 100 and so 180 take 20 is 160. So 154. Okay. So that's 154. Go away. Degrees. Now, these two angles are exactly the same at the base, okay? They're exactly the same angle. So all I'd have to do this 154 is divide it by 2, cut it in half. So when I do that, 154 divided by 2, and I might, bear with me for a minute, bring my trusty calculator up. Can I move that? Yes, I can. Okay, I'm going to say 154, divide that by 2 equals 77 degrees. All right, so my angle A is going to be 77 degrees, so that angle is going to be 77 degrees, and this angle down here is also going to be 77 degrees. All right, so it's that easy. So again, using the information we know about triangles to solve that problem. All right, one more to do, nice easy one. So again, you can pause this and get this done. Hopefully we'll have this done in about 10 minutes. Again, we've got an exterior angle here of 161 degrees, so use the information that I gave you down here about exterior angles. You may want to go back in the video if you need to, but using that information to see if you can find angle A in this diagram. Okay, so pause the video and off you go. Right, welcome back. All right, so we know that this exterior angle is 161 degrees. Okay, the information I gave you earlier, we know that the two opposite interior angles have to add up to equal this. Okay, we know we've got a right angle here, so that's 90 degrees. So very simply, I'm going to say angle A equals 161 minus 90 degrees. And that gives me, again, I'm going to bring up my trusty calculator here. Okay, 161 minus 90 equals 71 degrees. And that is my answer for angle A. So angle A equals 71 degrees. All right, hopefully that makes sense to you all. And you are ready to go in the, ready for class. All right, so I think we'll call it quits on that one. Very quick little observation though. If you witness or see someone rob an Apple store, does that make you an eyewitness? Eyewitness, get it? Apple, eyewitness. Anyway, on that note, I'm going to leave you and see you in class. And yeah, we're ready for that next exercise. Bye-bye.